In this video, I wanted to continue looking at algebra. So let's just review what we learned in previous videos. Algebra is the part of mathematics that's concerned with dealing with operations that contain letters and numbers. The most basic element of an algebra is an algebraic expression, something like 3x squared minus 3x plus x squared minus 8x and plus 7. Each algebraic expression consists of terms. So in this case, terms of this expression are elements like 3x squared minus 3x plus x squared minus 8x and plus 7. Term is always letters, numbers, and the sign in front of them. So that's a term of the expression. Each term could consist of either a constant or a variable. A constant is a term that never changes its value no matter what. So in this expression we have one constant, and that constant is 7. So that's our constant. Variables, on the other hand, are elements of expression, elements of expressions that can change values, because any number, any value can go into a variable. So let's take a look at term minus 3x. Letter x in this term denotes a variable x, and that variable could take any value. Depending on what value letter x takes when this expression is evaluated, the value of this expression would change. But for now, all we need to remember is that variables can have infinite number of different values in an expression, and variables are always denoted using letters. We also have what's known as coefficients. And coefficients are numbers that tell us how many times is a variable multiplied. So if we look at the term, this term over here, we have x squared is our variable, and coefficient of x squared is number 3. So 3 is a coefficient of x squared. In this case, on the other hand, we have a term of minus 8x. X is our variable, and minus 8 is the coefficient of this variable in this term. So that's all well and good, but what we want to do with an expression like this is to tidy it up, simplify it in such a way that the number of terms in this expression is as low as possible. In order to do that, we can add like terms and then see what we end up with. So let's see what are the like terms in this expression. To find like terms in an expression, we need to look at variables first and then look at their powers. So in this case, we have one variable in the expression, x, but in some terms, x is squared, and in other terms, x is in its base power, x to the power of 1. So like terms are terms that have the same letter and the same power. So 3x squared and plus x squared are similar or like terms. And in the same way, minus 3x and minus 8x are also like or similar terms. And finally, 7, which is our constant. If there was another constant, there would be like terms for 7. So to simplify it, all we need to do is just add like terms together. So 3x squared plus x squared is 4x squared, and minus 3x minus 8x is minus 11x, and finally plus 7 remains as so. So this is how we simplify terms. Sometimes expressions take form like this. We have 3, and inside the bracket we have 2x minus 1. We also can simplify that expression by removing the bracket, and in order to remove the bracket we need to multiply every term inside of the expression by the coefficient outside of the expression. So we have to multiply 3 by 2x, and we also have to multiply 3 by minus 1. If we do that, we're going to end up with 3 times 2x plus 3 times minus 1, which is the same as 6x minus 3. And that's our simplification. It gets a little bit more difficult when we have to deal with expressions containing multiplications of many brackets. So in this case, in this expression, we have 3x plus 1 in one bracket, and in the second bracket we have 2x minus 4. There is no sign in between the two brackets, which means that we have to multiply the two brackets. There is a way of doing it in the same way as we dealt with the previous problem. We have to multiply every term in the first bracket by every term in the second bracket. Let me show you how this would look like using what's known as the box model. So, box model, we just draw a simple box like this, and on one side of the box we write first bracket. So in this case, let's write 3x plus 1. So this side of the box comes out from the first bracket. And on the second side of the box, let's write what's in the second bracket, which is 2x and minus 4. See that we can divide the box into 4 different quadrants, and in each of those quadrants will contain a product of the elements on the side of the box. So take a look over here. Here we have 3x times 2x is equal to 6, and x times x is equal to x squared. We have 2x times plus 1 is equal to 2x. We have 3x times minus 4, which is equal to minus 12x. And we have minus 4 times plus 1, which is equal to minus 4. So what I did, I multiplied each of the elements of each bracket by the other bracket. 3x times 2x, plus 1 times 2x, 3x times minus 4, and plus 1 times minus 4. We can do it the same, very similarly, just using simple algebra without having to draw boxes. So we have 3x plus 1 is equal to 2x minus 4. And that's the same as 3x times 2x minus 4 plus 1 times 2x minus 4. Where did it come out of? Take a look. I took 3x and I multiplied 3x by every element of the second bracket, which is by second bracket. So that's what I did over here. 3x times 2x minus 4. And I also took plus 1 and I multiplied plus 1 by every element of the second bracket. So I have plus 1 times 2x minus 4. Now we can continue with our calculation and expansion. And we get 3x times 2x is 6x squared. 3x times minus 4 is minus 12. We have plus 1 times 2x is plus 2x. And we have plus 1 times minus 4, which is minus 4. Now we can start tidying up and simplifying this expression, which means that we have to add like terms. In this case, the only like terms are the constants, minus 12 and minus 4. 6x squared is not like 2x because it's squared, so they are not similar terms. So then what happens is we have 6x squared plus 2x and minus 16. By convention, I want you to start writing the highest powers on the left and then the constants on the right of your expression. That's the tidiest way to write this down. This example, on the other hand, we have to deal with different types of two brackets. I mean, similar, but just more terms in the second bracket. Again, similar way, if there is no sign between the bracket, it means that there is a multiplication between the two of them. So, as in previous example, what we have to do is multiply every element of the first bracket by every element in the second bracket. the easy way to do it is by rewriting. So if I rewrite the same expression, doing that multiplication, I'll get 2y times the second bracket y squared plus 3y plus 1 minus 7. We always have to be careful about that sign. Minus 7 y squared plus 3y plus 1. So let's do the multiplication. 2y times y squared is 2y cubed. 2y times 3y is plus 6y squared. 2y times 1 is plus 2y. On this side we have minus 7 times y squared is minus 7y squared. Minus 7 times 3y is minus 21y, and minus 7 times 1 is minus 7. Okay, so the next step is to identify similar terms and tidy it up. So we have just one variable, and we have that variable in 3 different powers: cubed, squared, and in base power 1. So cube would be we're looking for similar terms, none. Squares, we have plus 6y squared and we have minus 7y squared, so these are similar terms. And in power of 1 we have plus 2y and minus 21y, so that's another set of similar terms. And finally we have minus 7 on its own. So then if we tidy it up, we're going to end up with the following resulting expression: 2y cubed plus 6y squared minus 7y squared is minus y squared, plus 2y squared minus 21y is equal to minus 19y and minus 7. That's how you would do an example like this. Again, to get good at maths, you need to practice, so let me know if you have any questions, and thank you for watching.